Hello grade 12s and welcome to today's lesson where we are going to be looking at grade 12 and 11 trigonometry revision questions in preparation for your final paper 2. We're going to start this lesson off by looking at the concepts that you should be comfortable with. So let's get right into it. Checklist. So at the moment, you should be very comfortable with making sure that you know how to use your defining ratios. Your defining ratios, we are talking about sine theta, cos theta, and tan theta. So you need to know those ratios and how they refer and are applied on the Cartesian plane as well as in your right angle triangles. We are also going to look at our reduction formulae, where you reduce angles with your 180 degrees, your 360 degrees, as well as your 90 degrees, which are your cofunctions. Then we also look at our double and compound angles, and you will know that that is the new section of work that was covered in grade 12. That was the new stuff that you've done. Everything else I've mentioned up until now, you were taught in grade 11. Then we are going to apply the defining ratios, the reduction formulae, and the double and compound angle formulae, and we're going to use that to work with the identities and special angle values to simplify expressions without a calculator. So that is specifically what we're going to look at today. The other topics we need to also look at is how to find the general solution of a trig equation, and also to prove identities where we do our left-hand side is equal to our right-hand side. So I hope you've got pen and paper ready, the calculator on the side to check the solutions, because most of the questions we're doing today are requests that you do not use your calculator. So get ready and comfortable, and let's begin with question 1. Question 1. Answer this question without using a calculator. The point P, K and 8 lies in the first quadrant such that OP equals 17 units and TOP equals alpha as shown in the diagram alongside. Let's begin by looking at this information on the diagram. The point, now we know when we discuss a point, we are talking about a coordinate point that has an x and y value. So looking at this point here, where they've shown on the diagram, we know that the k value is also representing our x coordinate, and the 8 is our y coordinate. Immediately we can interpret this information and understand that OT is equal to K, and that PT has got a value of 8 units. That is how we interpret that information that has been given. They also tell us that the point lies in the first quadrant. Now when we are looking at trig questions, the fact that they tell us this lies in the first quadrant, they are telling us that our angle alpha is an acute angle. They then continue to tell us that OP equals 17 units. OP in this question is our radius, and they have marked this on the diagram for us. They then tell us that TOP is equal to alpha, and now that we've looked at the information that they've given us and interpreted on the diagram, let's go and look at what they want us to do. So the first part of this question for 2 marks asks us to determine the value of K. In other words, they want the value of OT. Now I hope that you've noticed that here we have a 90-degree angle. Therefore, this is a 90 right angle triangle, and we are thus allowed to use Pythagoras. And because we have been given 2 sides, we now can use our theorem to go find the value of K. So let's begin. We will start off with saying OP squared, because OP is my hypotenuse, is equal to OT squared plus PT squared. We substitute for the values that have been given. OP has been given as 17 units. OT is our value of K, which we want to find. And our value of PT is 8 units, and we square that according to the formula. Now, here you are able to write that as OT squared or K squared. And I prefer to start writing that as K squared because that's the value we're working with. And I also want to make this the subject of the formula because that is what we need to solve. Doing so, we're going to get our 17 squared, and we would need to subtract our 8 squared on the right-hand side of the equation, and therefore whatever you do to one side of the equation, we do to the other, and we now subtract our 8 squared on this side as well. Now, something to consider here, grade 12s. The questions did mention that you needed to solve this without the use of a calculator. However, there may be some of you who are not entirely comfortable, familiar what 17 squared is equal to, for example. That kind of calculation, you can use your calculator to work out. Even if you've done it mentally, always check. You don't want to get a question wrong because you've made a small mental error. Okay. So our 17 squared is equal to 289 minus 8 squared, which is 64. And that gives us a total value of 225 is equal to K squared. Now, we do not want the value of K squared, we want the value of K on its own. And to eliminate the square, we would square root. And again, following our rules of equations, whatever we do to one side, we must do to the other. The square root of K squared is K. And now our square root of 225 is going to be plus or minus 15. Now, some of you may be thinking, okay, where is the plus or minus coming from? And this comes from, you will remember in grade 11 when you did quadratic equations, you were taught if we had, for example, K squared minus 225, we would make that equal to 0. And this is the difference of two squares, and we would solve this by saying K minus 15 and K plus 15 is equal to 0. And therefore, we would get that K is equal to 15, or, whoops, I forgot my bracket there, or K is equal to negative 15. And once you understood that concept, you were taught that, well, if you've got one term squared equal to one term, which is a perfect square on the other side, we can just square root both sides. But when doing so, we must remember the plus minus so that we get our two values for our quadratic equation. So that is just a concept to remind you with that. Now, some of you may understand that and then think, right, so what is our answer? Do we take the positive 15 or do we take the negative 15? To answer that, we need to look at our diagram and see which quadrant our right angle triangle lies in. Looking back, we see that our right angle triangle lies in the first quadrant, and our value of x here would be positive as it lies on the positive side of the axes. Whereas if you were in the second quadrant, you would then have your negative value for 15. So to show the examiners that you understand that, we can then finish off by saying, therefore, k is equal to 15. And we now have our x-coordinate of point P. Right, let's move on to the next question. 1.2 requests that we write down the value of cos alpha. Now I want you to take note that we have now gone and put the value in. And I recommend that you do this in your exam. When you are writing, go back to your question paper and fill the information that you have solved onto the diagram. It just makes it easier for you to work out and to visually see what you've got on your paper. Right, let's go find the value of cos alpha. Questions such as these, I would recommend by now that in the exam that you pull your formula sheet from your paper, and on the formula sheet write down your trig ratios. So you could start off and sine theta, cos theta, tan theta, and this I recommend that you do at the beginning before you start answering your questions, and you would then have this and you then can fill this in. Now there are many poems, little stories, statements that you may have come across or that your teachers have given you to learn the ratios. There is Sakatoa, silly old hens cackle and hackle till old age, shelter your rear cause x-rays tan your exterior. You use whatever you are most comfortable with and what you find easiest to learn in order to have your trig ratios. Right. With this, we now can go back to our question where we have cos alpha. Looking at our diagram, our alpha is our angle, our acute angle in quadrant 1, and we, looking from our trig ratios, we know that cos of an angle is equal to the value of x over the radius. So we can write this answer as cos alpha equals. Now our x value we have found to be 15 units and our radius is 17 units, which was given. And the 15 over 17 is our final answer. And I really want to emphasize this. One of the common mistakes that we see learners make is they go and they write their answer as cos 15 over 17, and this is very, very incorrect. You need to remember that your alpha is the angle and 15 over 17 is the value of the ratio. So this would be your final answer. Please do not make that common error. Also, I just want to make sure that you understand and remember the concept of the quadrant and the values of your ratios. We are working in quadrant 1. Do you recall that in quadrant 1, all your trig ratios are positive? And if you, by mistake, got a negative value, you need to be able to stop and think, but wait a minute, I'm working with cos theta, or cos alpha in this case. I'm in quadrant 1, therefore my value must be positive. We want you to be able to think and interpret the answers that you get. Right, moving on to 1.3 now. If it is further given that alpha plus beta equals 180 degrees, determine cos beta. Now on our diagram, the only angle we've got is alpha. There is no beta. but you have also been taught how to manipulate equations. And by now, you should be comfortable with making beta the subject of the formula. This means that beta would be equal to 180 degrees minus alpha. And now, when we've got our cos beta, what we can do, instead of having beta, we can now substitute for the value of beta, which is 180 degrees minus our alpha. This brings us to our reduction formulae. In order to work this out, I want to revise with you the quadrants. So we know that in quadrant 1, all our trig ratios are positive. In our second quadrant, S stands for our sine theta, meaning that only sine is positive in that quadrant, and therefore cos and tan are negative in quadrant 2. And we know that tan is positive in quadrant 3 and cos is positive in quadrant 4. Recall that we have our 90 degrees value there, 180 degrees, 270 degrees, and 360 degrees if it's made a full revolution. Now, looking back at our 180 minus alpha, we know that if we were to subtract an acute angle from 180 degrees, that is going to take us into quadrant 2. Agreed? And in quadrant 2, the value of cos is negative. Therefore, our answer would be negative cos alpha. And from the previous question, we've learned that cos alpha has got a value of 15 over 17. Thus, cos beta has got a value of negative 15 over 17. I hope that you are able to see how the different questions relate to all the concepts we've worked with. So here we are dealing with a question where we're working with the aid of the diagram, doing our Pythagoras type questions, and yet we are looking at our concepts of our reductions, looking at the cast diagram, where are our different ratios positive and negative. Let's now look at 1.4. Hence, determine the value of sine beta minus alpha. Now, the word hence gives us a hint that we are likely going to need to use the information that we have calculated in the question before that to use and to work out or simplify our next question. So here where it says hence, determine the value of sine beta minus alpha, we know that we are likely going to need to use the information we found in 1.3. Now, when you look at a ratio such as that, what comes immediately to mind? I hope you've said your compound angle formulae, because inside that bracket we have got our beta minus alpha. So we do not have our 90 degrees or 360 or 180, which are our reduction formulae. We have got two values of angles which are unknown at the moment. We don't know their values. So this gives us a hint that we are going to need to use our compound angle formulae. Those formulae, together with your double angle formulae, are given on your formula sheet. And I highly recommend that you become familiar with this formula sheet so that when you are in the exam, you know immediately where your eyes need to go and find the formulae that you need. Also, by now you should have done so many practice questions that it's likely you know it off by heart. So let's start by writing the formulae down. We know that our sine beta minus alpha is going to be equal to sine beta times cos alpha minus sine alpha times cos beta. And that you could get from your formulae sheet. Now what is left to do is to go and find the values of the trig ratios. We've already found the value of our cos alpha and cos beta. So we now need to go back to our diagram to find the values of sine beta and sine alpha. Sine, going back to where we looked at our trig ratios, so it is back here, we see that sine of an angle is equal to y over r. We can therefore use the values of our y, which is equal to 8 units over our 17. Cos alpha we have seen to be 15 over 17 minus our sine alpha is going to be 8 over 17, and cos beta will be negative 15 over 17. Now, again, the question has stipulated that you must solve this without using a calculator. However, here, once you've done your answers and you've done your mental calculations, check using your calculator that you have worked this out correctly. So, 8 times 8 over 17 multiplied by 15 over 17 gives us a value of 120 over 289 minus 120 over our negative 289. Now, this over here, I recommend that you do not write that. And if you do, keep that in a bracket so that in your next step, you can see that your value here, when you've multiplied these two, you're going to get a positive answer of 120 over 289, which then simplifies, because our denominators are the same, we're going to get 240 over 289. With questions where your answer is a fraction, don't forget what you've been taught in previous years. You've been taught that when you give an answer with a fraction, you must ensure that it is in its absolute simplest form. 240 over 289 is in its simplest form and therefore is our final answer. That was a long question. So we're going to give you an opportunity to collect your thoughts, and we're going to go to a commercial break. Stand up, get a little stretch, and have something to drink. Take a little break, and we're going to be back shortly where we continue with another question and look at proving our identities and using the identities we've been taught in grade 11 and 12. See you soon. Welcome back, and I'm sure you are now ready to continue with question 2. Question 2 asks us to consider the expression. And here we have a look, and we see that we have a fraction, and we've got 1 minus cos 2x minus sin x over sin 2x minus cos x. I hope that you immediately recognized and saw that we have a 2x here and a 2x at the top. which is our double angles. So how do we tackle these kind of questions? There's no need to panic. I've seen a lot of students get very flustered and nervous over questions like these, and they always say they're so hard and I can never get them, and etc. If you know your theory and the things to look out for, they're actually a lot of fun. So before we actually go and do this question, I want you to have a look at the kind of mind frame that you should be in when you look at these questions. What I mean by this is, so far, and we see that from here they're asking us to prove, but we're not even going to get to that just yet. I want to get you into a good space, and I want to see, right, let's have a look at what we learned in grade 11. And in grade 11 we were taught an identity where sine squared theta plus cos squared theta was equal to 1. And I'm sure you remember that. Now, what we also need to remember is not only can we work from the left-hand side to the right-hand side. What I mean by that is, if you see sine squared plus cos squared theta, many of you are able to recognize that that's got a value of 1. But I need you to also train your brain that every time you see a value of 1, know that that has got the same value as sine squared theta plus cos squared theta, and that you can change that. In other words, I need you to be able to think almost backwards. Still looking at this identity, I also need you to recall that if we make sine squared theta the subject of the formula, that sine squared theta will have a value of 1 minus cos squared theta. So you need to look and remember that in an exam, if you see that, or in any question, if you see 1 minus cos squared theta, that you immediately know that it is equal to sine squared theta. But further, I also want you to remember that this is a difference of two squares, and that 1 minus cos squared theta can be factorized to 1 minus cos theta to 1 plus cos theta. So if you are to see an expression that includes this, we want you to be able to recognize that that is equal to 1 minus cos squared theta, which is then equal to sine squared theta. In a similar way, and I'm just going to change color here so that you can see, in a similar way, we have the same thing, that if we make cos squared theta the subject of the formula, that'll be equal to 1 minus sine squared theta, which is also the difference of two squares. So you would also get 1 minus sine theta, 1 plus sine theta. My recommendation is, I said early on in the lesson that when you get to your paper 2 and paper 1 for that matter, is detach your formula sheet from the back of your question paper and have it on the side next to you while you are working. And together with writing your trig ratios, I would go and write immediately sine squared plus cos squared is equal to 1. It is an identity that is not given on the formula sheet. And underneath it, write these factorized and simplified forms of the identity so that your brain will recognize it if it comes across it in the paper. Now let's look at the other identity that we learned and worked with in grade 11, which is our tan theta is equal to sine theta over cos theta, and the variations that we can work with on this one. So we've been taught that tan theta has the same value as sine theta divided by cos theta. And now that you have been taught double angles, I want to bring to your attention that if you are given sine 2 theta divided by cos 2 theta, that would be equal to tan 2 theta. And that is now a variation of the identity that you will see in grade 12 now that you've dealt with your double angles. Which brings me now to our grade 12 double angle formulae. Let's just revise those. So up until now we have looked, so this year you would have been taught that if you have sine to theta, that this can be written as 2 sine theta times cos theta. And this is given on your formula sheet. The one that is not given on the formula sheet is half sine to theta. And that is equal to sine theta times cos theta. And let's have a look why, because a lot of the times you will find you will be given this in an expression, and I often hear my students say, oh, if only there was a 2 in front there, then we could use our double angles. But you can use your double angles if there isn't a 2 in front. And let's have a look at why. If I keep this half on the outside, and I know that my sine 2 theta opens up to 2 sine theta times cos theta. A half multiplied by 2, when that is distributed, will give me a value of 1, which is then equal to sine theta times cos theta. I now hope that this along here makes more sense now that you have seen this over here. And these are the things I need you to keep in mind when you are dealing with your sine 2 of an angle, or your double angle with sine. Now let's look at cos, because cos has got many options. Well, not many, but there are 2 options. So if we look at cos 2 theta, this is given on your formula sheet, cos squared theta minus sine squared theta. Be very careful with this, that you do not make the common mistake and tell me that it is equal to 1. It is not. Remember, it must be cos squared theta plus sine squared theta in order for it to be equal to 1. So be careful that you don't make that common mistake. What is not given on the formula sheet is that is then, of course, the difference of 2 squares, which can be simplified to cos theta minus sine theta multiplied by cos theta plus sine theta. So again, what we want you to be able to recognize, if you are given this in an expression or an identity, that you will understand that distributes and opens up to cos squared minus sine squared theta, which is then equal to your cos of your double angle. Okay, the second option is cos 2 alpha is equal to 1 minus 2 sine squared theta. This is also given on the formula sheet. Be careful, the 2 is not a perfect square, and thus this cannot be factorized using the difference of 2 squares. Our other option that is given on the formula sheet is that cos 2 theta is also equal to 2 cos squared theta minus 1. And again, our value of 2 is not a perfect square, and thus that cannot be factorized any further. When we look at cos, because we've got 3 options to cos of a double angle, my recommendation is when working when you are proving an identity, keep your cos 2 alpha as cos 2 alpha or 2 beta or whatever the double angle is, until you've worked through and realized what do you need, keeping an eye on the right hand side and saying, right, do I have ratios with sine or cos in it, because that will give you an idea as to which of the 3 options you should choose. Now let's take this and put it into practice and do question 2.1. prove that 1 minus cos 2x minus sine x over sine 2x minus cos x is equal to tan x. With questions such as these, whenever you are asked to prove, or if they say show that, all right, you are dealing with an identity and they are asking you to prove that the left-hand side is equal to the right-hand side. Your layout and format in this question is very important, and you must remember that we need to start with the question with left-hand side equals, and you work with the left-hand side, which is in the case here, we're going to work with that. But there are certain cases where you would start working and manipulating and simplifying the right-hand side, and then you would say right-hand side equals, and you work in that way, keeping your equal signs underneath one another so that it's neat and easy to follow and mark. So just bear that in mind. It's very important that you follow that format. So let's begin. In this question, we can see that we're going to work with our left-hand side. It gives us more material to work with, and we begin with saying left-hand side equals. Now, you would recall that I said to you just now, I know that this is a double angle, but there are 3 options to change that into, and I don't know which option I want to use just yet. So what I'm going to do is I'm going to keep that with the double angle, but remembering that I will want to change it later on in the question. However, our sine 2x only has one option, so I'm going to immediately change that to 2 sine x times cos x. And just to help you here, if you do not see what I'm doing, the sine 2x is now, I've rewritten it with its equivalent value there. Okay, and we continue with writing minus cos x. Now, looking at my numerator, I will also bear in mind that this little 1 over here, okay, we remember at the back of my mind, say, right, I know that I can change that 1 and substitute sine squared plus cos squared x in this case, because that's the angle they've given us. So we keep that in mind. I'm not going to do it just yet because I don't know if I want to, but we keep it in the back of our mind in case we need to use it. However, in our denominator, we see that we have a common factor. And I'm going to begin by working with my denominator and taking out the common factor there. And let's see what that simplifies to. So we take out our cos x as our highest common factor, and we would be left with 2 sine x minus 1. Now, proving identities, you're not left in the dark. When working with the left-hand side, even though we've got the right-hand side on the other side and we're ignoring it for now, you keep it with there and you keep thinking, okay, right, that's where I want to get to. That is my end goal. That is the destination. We want to get to the right-hand side. And what I mean by that is when we're looking at this, sometimes we get very carried away with simplifying and factorizing and etc., that we forget to look at what our end point is. What are we trying to do? And we know that tan x is equal to sine x over cos x, which means I want to now simplify this further and be left with a sine x at the top and a cos x at the bottom, which if I look now at my denominator, I've got one term and I have a cos x at the bottom already, which indicates to me that I actually want to get something in my numerator factorize that I've got a bracket that with a 2 sine x minus 1 so that I can cross cancel that. And that is now going to help us decide what we need to do with our numerator. So having a look at that, we can now decide that 1 minus, if I want 2 sine x minus 1, this cos 2x, we are going to want to change to a 1 minus 2 sine squared x. And the reason being is because we want to have sine x over cos x, so I don't want any cos's in my numerator. So that is why we're not choosing the other two options. And there's nothing to do with, well, there's nothing for us to do with the sine x, so we rewrite it and we keep our cos x to sine x minus 1. We can now, we remember we distribute, so this is going to become 1 minus 1, which now we know that those are going to cancel out, therefore we don't even have to worry about the sine squared x plus cos squared x. So do you see why I didn't want to change it immediately? A negative multiplied by negative is going to give us positive 2 sine squared x minus sine x. And I hope you are beginning to get excited and see that this is beginning to work out and we are getting very close to our sine x over cos x. So 1 minus 1 becomes 0, and then we recognize that we have got a common factor of sine x at the top, which we can now take out. So we begin with sine x, and we then left with 2 sine x minus 1. And at the bottom, we have our cos x 2 sine x minus 1. And because we have one term over one term, we are allowed to cross cancel, and this is where it gets fun. We can cross cancel, and we are now left with sine x over cos x, which we know is equal to tan x. And we can then finish off with saying, therefore, my left-hand side is equal to my right-hand side. And that is such a good feeling. And you now know that you've earned your 4 marks by proving that. Okay, and it is fabulous when we get to that point. It's now time to look at question 2.2, the second part of the question. Which brings us to how to solve a trig equation. Let's have a look at the question. The above expression is undefined if sine 2x minus cos x equals 0. Solve this equation in the interval where x must be greater or equal to 0 degrees but less than or equal to 360 degrees. There's a few things that I want to mention here before we begin. Did you notice that our sine 2x minus cos x is our denominator? And correctly so, that the expression would be undefined, i.e. there would be no true value because it's our denominator, and we know that our denominator is not allowed to be equal to 0. We know that. It's a concept that you were introduced to when you did numerical fractions at primary school. Now that concept doesn't change because we're dealing with trig. So wherever you have a denominator, know that there would be certain restrictions for that angle because the value of the entire ratio would not be equal, would not be allowed to be equal to 0. Returning to the question here, they then ask us to go solve the equation. Now, with trig equations, you are either going to be asked to solve for x or solve for theta, in other words, to find the values of the angles. So in this example, they want us to go and find the exact values that the angle is going to be and will not be able to be because we are dealing with an undefined question. However, there are also the trig questions where they ask you to find the general solution. Sine 2x minus cos x is equal to 0. So we begin by finding our general solution. We need to do that first. However, again, we need to open this up because we're not in a position where we can find the general solution because we don't have a trig ratio equal to a value. So our next step is to rewrite sine 2x as 2 sine x times cos x. We need to simplify this, minus cos x, and that is equal to 0. Now we notice that we have a common factor of cos x, so we rewrite this as 2 sine x minus 1 equals 0. And if you recall from grade 11 when we learned how to do our equations and quadratic equations, the cos x and the 2 sine x minus 1, the product is equal to 0. So this allows us to say cos x must be equal to 0, or 2 sine x minus 1 must be equal to 0. And we can now work from here and begin solving. I'm going to do this in 2 separate colors so that you can see what we work with here. Now, when we've got a trig ratio equal to a value, this is the point where you can now put into your calculator second function cos equals second function cos 0, and you press the equals. So let's have a look at what we do here. So you would begin, ensure that your calculator is in degree mode, and you're going to press shift, which is your second function, cos value of 0. But before we get the answer here, okay, I want you to think in your head and visualize your cos function, your cos graph, and think where 0, okay, where you've got your value, where is the cos graph equal to 0? What are the coordinates? You thinking about that? Again, let's have a look at what we get as our answer. Did you think of 90 degrees? Now think where your cos graph has got the value, where your y value is 0, our x coordinate is 90. Okay, so I hope you are making the link between the two concepts. Therefore, we can now say that x, because here we're working now with an x and not with our not with theta, but now x represents the angle, so we would say x equals the 90 degree that the 90 answer that we got on our calculator. That is what I'm talking about when we say reference angle. So that now is going to be 90 degrees plus 360 degrees. Okay, and when we're working with cos, we know then we can say or x is equal to negative 90 plus 360 degrees. Okay, and k is an element of integers. So we've now done the part for the cos. So this is now what we've done over here. Okay, but we need to remember that we've now still got to go work out our value here for the 2 sine x minus 1 equals 0. So we begin with, remember, then the strategy is we want to get our trig ratio on its own. So we would begin by writing 2 sine x is equal to 1. We would add 1 to both sides of the equation. And to get sine x on its own, we would divide by 2 further. So that would give us sine x is equal to a half. And we look at the value over here that we've got, that we get a half, and we look and say, right, this is okay because the half does lie between negative 1 and 1, remembering our restrictions. We proceed now by finding the value of x. So we go to our calculator and we will press shift sign, and we put our value of a half in, and we get 30 degrees. So now we know that x is going to be equal to 30 degrees, and that's my reference angle, plus 360 degrees. Okay? Or x is equal to, I 180, and I'm just going to write it a long way so that you remember that is our general solution, where we say 180 minus the reference angle, which will give us the 150 plus our 360 degrees K, which of course then that is our 150 degrees plus 360 K. So what we have now is our general solution for both. But the question asked us to solve. We need to go find the specific values that the angles will be, and we've been given an interval as well. So they said solve the equation, and the interval needs to be between 0 and 360 degrees, and it can include both those values. So how do we do that? Well, we use the general solutions that we've been given, and we would go and substitute our values of an integer into K to get the solution. So we can start by saying X is equal to 90 degrees, and I'm getting this from the solution over here because 90 falls into my the interval that was given. Now if we go and substitute a value of 1 into this K here, we would get 360, and 360 plus our 90 degrees is going to give me a value that falls out of the interval that they've given us. So I don't need to worry about that. In a similar way, if I substituted -1 into the value of K, we're going to get negative 360 degrees plus 90, which will put us out of the interval where they gave us, because we're getting a negative answer and we can only get the solutions between 0 and 360. That's what was asked. So we begin and say, right, X is going to be equal to the 90. Now we go and look at the second part that we got over here. The X is equal to negative 90 plus 360. So we begin the same. If we start off by substituting 0 into our K, which is an integer, we will get 0 and we were left with negative 90 degrees. But that falls out of our interval. So we go and now we substitute 1 into the value of K, which will give us positive 360, and if we subtract 90 from that, we would get an answer of 270 degrees. Now 270 degrees lies in the interval that was given to us, so we would then say or X is equal to 270 degrees. If we put a -1 back into the K, we would get negative 360 minus 90, which is going to give us a negative answer which falls out of our interval. So these are the two solutions that we get when cos X is equal to 0 in the interval. So now we've got specific solutions. Do you see that? We now need to consider the other equation, and let's go and look at the values that we had over here. We now know that looking back, we got our 30 degrees. Now that's 30 degrees. So if we substitute 0 into K here, we're going to get 0 plus 30 degrees. And 30 degrees lies in the interval that was given. So we then say, or X is equal to 30 degrees. Substituting a +1, we would get 360 plus 30. That falls out of the interval. Substituting -1 in, we would get negative 360 plus 30, which falls out of the interval as well. So we do not worry about those values. We move on to our next one, where X is equal to 150 degrees. And if we start off by substituting 0 into the value of K, we would get 0 plus 150. And because 150 falls within the interval we were given, we would then write or X is equal to 150 degrees. We then follow the same procedure, substitute 1, that would give us a value out of the interval. Our -1 plus 150 falls out, and from that we can see all the other integers we would substitute into K give us solutions that fall out of the interval. Therefore, these solutions that we've got over here are our final answers. So if the value of x were to be 90 degrees, 270, 30, or 150, the identity we looked at the beginning would be undefined, because that's what they asked us for. The above expression is undefined if that is equal to 0. Solve. And I like to give these in order, so I would finish the question off by then writing x is equal to 30 degrees, or x is equal to 90 degrees, or x is equal to 150 degrees, or x is equal to 270 degrees. By no means do you have to do that. It's out of habit that I do, and that would be your final answer for this question. Thank you for joining us, Matrix, for today's lesson on revising trig, and we wish you the very best of luck for the upcoming exams. Goodbye.